Hello, welcome to the third session of divisibility rules. The previous two sessions have discussed divisors which are of the form 2 power x, 5 power x and 10 power x. This video 1 and then video 2 divisors which are 3, 9, 11. Now the current session I'm going to discuss how to find the reminders when the divisor is 7, 13, 37 and how to find the remainder as well and the approach as well. In the previous two classes I have taken n as PQRS. This P is nothing but P triple 0 plus Q double 0 plus R 0 plus S, and this is nothing but P into 1000 plus Q into 100 R into 10 and plus S into 1. This is nothing but P into 10 cube, Q into 10 square, R into 10 power 1 and then S into 10 power 0. And we try to find the reminders when the divisors are 2, 4, 8, that is of the format 2 power x, and then 5, 25, 125, which are of the form 5 power x, and then for 3, 9, 11 also. Now this session we are trying to find n divided by 7 remainder. So whenever n divided by 7, since n is p into 10 cube and so on up to s into 10 power 0, this by 7. This is nothing but at the end, that's going to be p into 10 cube by 7 remainder and so on up to s into 10 power 0 by 7 remainder. This we can write as p by 7 remainder into 10 cube by 7 remainder. Yes, we can write this format, q by 7 remainder into 10 square by 7 remainder and so on up to s by 7 remainder into 10 power 0 by 7 remainder. Now here, this remainder that start from unit term 10 power 0 by 7, that is 1 by 7 remainder is 1, s by 7 remainder depends on s, so s into 1 is s, this is going to be s by 7 plus we have the next one which is r into 10 power 1 by 7, so 10 power 1 by 7 remainder is 3, r by 7 remainder depends on r, so that is going to be 3 times of r by 7. The next one is 10 square by 7 which is 2, the remainder is 2, q by 7 remainder depends on q, so that's going to be 2 times of q by 7. Next one is 10 cube by 7, 10 cube by 7 remainder is 6, p by 7 remainder depends on p, so that's going to be 6 times of p by 7. Now finding 10 cube by 7 remainder, if you're trying to say that 10 cube is 1000 by 7, then that lead automatically, that lead a lot of time. Don't try to do it. Let me tell you how to approach. 10 power 0 by 7, the remainder is 1. Now 10 power 1 by 7 remainder, that we can easily find. Now let's move to 10 square. 10 square by 7. Should we take 10 square as 100? No. We can directly take 10 power 1 and 10 power 1 by 7. This is nothing but 10 power 1 by 7 remainder into 10 power 1 by 7 remainder. So 10 power 1 by 7 remainder, we know that it's 3. So 3 into 3 is 9. 9 by 7 remainder, that's going to be 2. Now when we're trying to find 10 cube by 7 remainder, either you can write this one as 10 power 1 into 10 power 1 into 10 power 1, or you can write this one as 10 square into 10 power 1, whichever is convenient for you. Now I say that 10 square into 10 power 1 is quite simpler. 10 square remainder, we know that it's already 2. 10 power 1 remainder, we know that already 3. So by 7, so that is 6 by 7, so the remainder is 6. You can understand this in a different way again. Now 10 square by 7 remainder, that we know that it's 3. 10 cube by 7 remainder is nothing but 3 into 1 more 10. That's it. 30. The previous term remainder into the additional power we are adding. That's it. Now that's going to be 6. Now 10 power 4 by 7 remainder is nothing but 10 cube remainder, which is 6, and 1 more 10, that is 10. That is 6 into 10, 60. 60 by 7, 4. This way you can solve. Now here we've got the reminders as 6 times of P plus 2 times of Q and 3 times of R, and then last one is 1 time of S. It looks like the same way as we have done it for 9 and 11. When we are trying to divide that number by 9, we needed every single digit. The same is the case for 11 also. Whenever we are trying to divide a number by 11, we just need the last 3 digits. We just need every single digit. However, what happened when we divide by 9 is this appears like P by 9 plus Q by 9 plus R by 9 plus S by 9, and when we're done by N by 11, this appears like 10 times of P by 9 plus 1 time of Q by 9 plus 10 time of R by not 9, actually it's 11 plus 1 times of S by 11. Look at this one. Whenever we are trying to divide N by 7 or N by 9 or N by 11, we need every single digit. However, the advantage for N by 9 and N by 11 is the digits are multiplied by either 1 or minus 10, either 1 or 10. Here N by 7, every digit is multiplied by a different number. How can we really solve? Can we really take like 6 times of first P's, 2 times of Q, 3 times of R, or 1 time of S? What happens if we have got 10 digits? What happens if we got a bigger number, 300 digits number? Should we go on adding? Should we go on multiplying every number and then adding it to the remaining numbers? That's an impossible task in the examination. Now, what can we do here is, we just need to eliminate the 6, 2, 3, and we just need to have a very limited number of digits. If at all we cannot eliminate any digit, we need to multiply the digit with a very simple number like 1. Whenever we multiply any number by 1, so we just get that same number. How can we do this one is like, pay attention. If I have like PQRS, let's say I'm taking the same number, we can write this as P000 plus Q00 plus R0 plus S, or else I can write this number as PQ00 plus R0 plus S, or the same thing we can write as PQ00 plus RS, or we can simply write PQR0 plus S, or we can simply write P000 plus QRS. Now this is the big advantage. Now once you understand that we can write a number in any one of these things, then we can apply it. Now how can I try to apply this one is, let's take this number as PQRS. I'm trying to write this number as P000 plus QRS. This is nothing but P into 1000 plus QRS into 1. In such a case, this is going to be P into 10Q plus QRS into 10 power 0. Now, we know that if it is 10 power 0, it's going to be 1. So, it is going to be 1, and QRS depends on QRS by 7. Now, how much is 10 cube by 7 remainder? That's, we found that it is 6 actually. Now, if it is 6, we can write it as minus 1. I explained in the previous video by saying that, let's say if we are trying to write 7 by 7, that's remainder is 0, 8 by 7 remainder is 1, 9 by 7 remainder is 2, 11 by 7 remainder is 4. Like this you can say 6 by 7 remainder is 6, 5 by 7 remainder is 5, or else you can write it as minus 1, minus 2. Look at this, these are in increasing order. So this is a series actually. It starts from minus 6, minus 5, minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, 5, 6, and then again it becomes 0. This is how we can write. It's not that 6 by 7. Let's say if you want to say 8 by 11, then you can write the remainder as minus 3. Negative remainders are not possible, but this is very, very convenient. Now, whenever you come across a remainder as negative remainder, to find its original and positive remainder, just add the divisor to it. Now, here in this case, minus 3 divided is 11, so minus 3 plus 11, the remainder is 8 here. Now, we can apply this one to solve this problem. That is, this number, it's going to be This is going to be 10 cube by 7 minus 1, so minus p by 7. Look at this one, we are down to simple additions and subtractions. Now let's see how we can apply this one. This one, let's take p equal to a b c d e f g h I j k l. I've taken a 12 digit number. What we can do is, this is nothing but ABC, and then we have got 9 zeros, plus DEF, we have got 6 zeros, plus GHI, we have got 3 zeros, plus JKL. This is nothing but ABC into 10 power 9, plus DEF into 10 power 6, plus GHI into 10 cube, plus JKL into 10 power 0. Now when we divide this number, let's say n, this number divided by 7, this is nothing but the whole number divided by 7, that is ABC by 7 remainder into 10 power 9 by 7 remainder, DF by 7 remainder into 10 power 6, and so on. Now the whole thing is 10 power 0 by 7 remainder, it is obviously 1. JKL by 7 remainder depends on JKL, so JKL into 1 is just JKL by 7. Now 10 cube by 7 remainder, the remainder is minus 1. GHI by 7 remainder depends on GHI. GHI into minus 1 is minus GHI. So that's going to be minus GHI by 7. Now 10 power 6 is nothing but 10 cube whole square. Now 10 cube remainder is minus 1. So we can directly say that 10 power 6 remainder is minus 1 whole square, which is plus 1. So that is plus 1 into DEF by 7. Now 10 power 9 is nothing but 10 cube whole cube. 10 cube remainder is minus 1. So minus 1 whole cube is going to be minus 1. Minus 1 times of ABC is going to be minus ABC by 7. Look at the advantage that we are getting here. We have eliminated every single number, and now we are down to just simple additions and subtractions. This you can write it as JKL plus DEF minus of GHI plus ABC by 7. Way simple. Now we can find the remainder. Let's take an example like 1, 2, 3, 4, 5, 6. Now what we have done is like 3 numbers as a cluster. Starting from unit term, you just divide the number into a cluster of 3. This is into 10 power 0. This is into 10 cube. So this becomes plus 4, 5, 6, and this becomes minus 1, 2, 3 by 7. That is 333 by 7. Now it's very easy. Very easy. That's remainder is 4. So what we need to do? First, let's take what we need to do here. Whenever you come across A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, like this, you just need to divide the number into club of 3, starting from unit digit. So that is PQR is 1 cube, MNO, JKL another cube, another one GHI, DF. Now the first one will take plus sign, second one will take minus sign, third one plus sign, fourth one minus sign, fifth one plus sign, sixth one minus sign. That's it. Now add all the clusters, that is plus clusters, alternate clusters, and subtract the remaining sum of the remaining alternate terms. That's very easy. We have a very big number. Now here the cluster size is always 3. You can have a liberty of doing this one in a different way. Let's say A, B, C, D, E, F, G, H, I. Let's say I stick to JKL only. What you can do is, instead of taking a club of 3, you have the flexibility of choosing a club size as 6 actually. So I mean that this is going to be 10 power 0 and this is going to be 10 power 6. So 10 power 0 remainder is 1. So as well as 10 power 6 remainder is also 1. So it means the number is ABCDEF plus GHI JKL by 7. If you are comfortable with this one, and then if you just want to add only digits, then this one. If you want to see that okay, addition and subtraction are both are taking the same time for me, then you have the flexibility. So very simple. Now if at all, let's say we have got a b c d e f, and let's say only g, we have got 7-digit number. What can we do here is quite simple. Start from unit term, divide the number into club of 3 3. So e f g, club of 3 3. Then the next club is going to be b c d. However, the one digit which is left is a, which is a single digit, so you can just put zeros here so that the size is 3 here. So this one will take plus, this one will take minus, this one will take plus sign. So that's going to be EFG plus A minus BCD by 7. This is how you can do. So what we have done is quite simple. We have taken 10 power 0, 10 power 1, 10 square, 10 cube and so on, and we try to divide every term, every number by 7. So the first one we have got is plus 1. Now as we progressed, we have got the remainder as minus 1. So whenever we find that another remainder is 1 or plus 1 or minus 1, we can stop there. That's it. From then onwards, what you need to do is try to see the powers of these reminders. Now here for 10 power 1, the power is 10 power 0. For minus 1, the power is 10 power 3. Now the difference between the powers is 3. It means the club size is 3. Once you have divided the number into club of 3 3, and the club size is, we know that it's 3, and clubs must be divided starting from the unit digit. Once you have divided the club size, what you need to do is check the signs of reminders. One is plus 1 and the second one is minus 1. So put plus 1 for the first club, for the first 3-digit one starting from unit term, and then alternately you just put plus 1 minus 1 plus 1 minus 1. This method you can apply for any divisor. Whenever you come across a new divisor, what you just need to do is take 10 power 0, 10 power 1, 10 square, 10 cube, 10 power 4, 10 power 5 and divide by that new divisor. Obviously for 10 power 0, the remainder is going to be always plus 1. Now you just need to go ahead and then try to find the divisor which is either plus 1 or minus 1. Then it's over. Then just check the difference between the powers and then divide the number into club of the club size depends on the difference of the powers. Now the same thing, we have got a new one, divisor n by 13. What we just need to do is, like, instead of trying to divide the PQRS, what you just need to do is first 10 power 0 by 13. Okay, remainder is plus 1. Very good. 10 power 1 by 13. The remainder is 10, or you can take it as minus 3. Now the 10 square by 13. 10 square, don't try to write it as 100. 10 square is nothing but 10 power 1 into 10 power 1. So that is remainder is minus 3 into minus 3, that is plus 9. Plus 9 by 13, that's 9. Now next one is 10 cube by 13 remainder. 10 cube by 13 remainder is nothing but 10 power 1 into 10 power 1 into 10 power 1, or you can directly say 10 square into 10 power 1. 10 square into 10 power 1. So 10 square into 10 power 1 is 9 into minus 13. That is, this is 10 square into 10 power 1 by 13 remainder. That can be 10 square by 13 remainder into 10 power 1 by 13 remainder. Here these reminders are 9 into minus 3 by 13. That is minus 27 by 13. Forgot about negative sign. First find the remainder for 27 by 13. Remainder. So that is 1. So that's going to be minus 1. Now we have got minus 1 remainder. Now when we have got minus 1, try to remember that 10 power 1 by 13 remainder, we have got it as plus 1, and 10 cube by 13, we have got the remainder as minus 1. Now check the difference between the powers. It's 0 and it's 3. Now the club size is 3. Now once it is finished, check the signs here, plus 1, minus 1. So the first club, that is the first 3-digit club starting from unit term, will take by plus sign. The next club will take minus 1. The next club will take plus 1. So it's plus 1, minus 1, plus 1, minus 1 alternatively. That's it. N divided by 13. Same is the case. If I got like 1, 2, 3, the next one is like 7, 8, 9. Then club of 3, 3. So this one is plus sign, this one is minus sign. So that is 789 minus 123 by 13. That is 666 by 13. The remainder is 3. Or else, let's say we have got 1, 2, 3, 4, 5, 6, 7, 8, 9. So what we can do is like club of 3, 3. This one take plus, this is minus, this is plus. So obviously it is 789 plus 123 minus 3, 4, 4, 5, 6 divided by 13. Or else you can do one thing actually. You can take 1, 2, 3. Then the whole club size is big size, that is 6. So that means that this number is going to be 10 power 0 and this is going to be 10 power 6. Now we know that 10 power 0 remainder is plus 1, 10 cube remainder is minus 1. As a result, 10 power 6 can be written as 10 cube whole square, that is minus 1 whole square is plus 1. Now you can straightforwardly say it's like 4, 5, 6, 7, 8, 9 plus 123 by 13. You have the liberty of choosing any one of these. You just need to do the same process. Now the final one is n divided by 37 remainder. That's like 10 power 0 by 37 remainder. That is plus 1. 10 power 1 by 37 remainder. That's obviously 10. Don't try to write it as minus 27. The next one, 10 square by 37. The remainder is how much? 26. Now 10 cube by 37. The remainder you get is plus 1. Check this one. We have got plus 1, plus 1. We have got 3 and 0. So now the club size is 3. So what is the cluster size? Cluster size is 3. Divide the number into clubs of 3, 3, starting from unit digit. And then after that, check the plus sign. Enough. Just like this, if we have A equal to A, B, C, D, E, F, let's take. And n divided by 7 or 13 or 37. The first step, step 1 is take 10 power 0 divided by 7 or 13 or 37. Find the remainder, that is plus 1. And it's now 10 power 1 term, 10 square, 10 cube and so on, divided by 7 or 13 or 37. Once you got the remainder is plus 1 or minus 1, stop here. Step 1 is completed. Step 2, check the powers of 10. Step number 3, difference of the powers. Step number 4, divide the number into clubs of, that is like S3. The next one, S5, is assign the both positive or negative signs. Enough. Then you can do the simple addition or subtraction process. That's what you can do. Now let's say I have written for 7 and 13. Now the remainder depends on some of the alternate clusters starting from the first cluster and some of the remaining alternate clusters of n. Now we have taken a simple one, cluster size is 3. You can take cluster size as 6 so that you can add all the clusters. If you are taking the cluster as 3, you just need to add alternate clusters and also subtract the sum of the remaining alternate clusters. If you take the 6, then you can add every cluster. If you take 9, then you just need to do the same process, like add alternate clusters and subtract the remaining alternate clusters. I have taken n equal to A, B, C, D, E, F, G, H, I, J, K, L. So I have taken 12 digits and then I have done it for 7 and 13. For 37, it's the same process, but we just add every club. For 7 and 13, we just add alternate clubs and subtract the sum of the remaining alternate clubs. Here, we just need to add every single alternate club. That's it. What happens if you come across a new divisor? You just need to do the same process. Take the base, that is 10 power 0 by the divisor, 10 power 1, 10 square, 10 cube and so on until you find the remainder as again as 1. Whether it is going to be plus 1 or minus 1, just stop there and check the difference between the powers and then divide the club into clusters of the size, that is already the difference of the powers. Start the division of the clusters from unit digit. That's it, enough. Should we really come, should CAT really is this much different, this much difficult? It need not be. This is just one simple thing. It's not difficult actually, it's unfamiliar. That's it. CAT examination, n divided by 13, n divided by 37, they are yet to be asked in CAT. So you are at advantage once you understand how to solve whenever the divisor is 7, 13, 37, some other numbers. With this one I finish. The third one, the divisibility rules. The final one, in the next video I'm going to take the divisors in the format which are 10 power x plus 1 format, 10 power x minus 1 format. With that one we finish divisibility rules. Once we finish the divisibility rules, I'll give you a worksheet. You can solve all the questions. After that we will solve all the divisibility rules questions given in CAT exam in the last 25 years. Thank you.